Hello, this is the second in a two-part video on quadratic functions, and this video is focusing on applications. There was a previous video that focused on graphing and characterizing our quadratic functions. So if you're having questions about that, please go ahead and take a look at that other video. Right now we'll take a look at applications. There's two major types of applications that we see at this level with our quadratic functions, and one is projectiles. So we kick a ball, we hit a golf ball, we throw a ball off a building. All of these are types of projectiles, and usually we're given an equation that is a quadratic that models the flight of whatever we're projecting. So in this case, we have an archer, and the archer is releasing an arrow, and it follows a path represented by f of s is equal to negative 0.005x squared plus 2x plus 5. So we have an archer here. He has an arrow. This arrow is going to shoot, and it's going to follow a parabolic path. And eventually, we're going to come back and hit the ground. So this is the archer who is standing on the ground. We're going to come back and hit the ground some point over here. Okay, so we want to know, so f of x is the height, and x is the distance in feet. So this is kind of like our x, y axis. Okay, we want to know what its maximum is and where it occurs. So our maximum is with parabolas is always the vertex. So we want the vertex of this. And now, just like with any other quadratic function, when we have it in ax squared plus bx plus c, our vertex is going to be at negative b divided by 2a is our x coordinate, and then we just plug that back in, f of negative b over 2a, to find the y coordinate. So let's go ahead and take a look at this. Well, our negative b, negative b over 2a, our b is 2. So this is going to be negative 2 divided by 2a. This is our a, the 0.005. Okay, plug this into our calculator, we get this is 200. So that's our x coordinate. That's this dimension here. This is 200 feet. 200 feet. Right? We want to know how high we go up. So to find the y coordinate, that's our y coordinate, we have to plug this in. We need to find f of 200. So we're just going to plug this in. This is negative 0.005 times 200 squared plus 2 times 200 plus 5. And when we calculate that, we get 205. So this dimension is 205 feet. So this point here is 200, 205. Okay, or we can say it has a maximum of 205 feet at 200 feet from where the archer released it. Okay, so that's the first thing that we want to know. So we're just going back to our equations that we talked about for quadratics. We want to find the maximum height. That's going to be our vertex, and we can plug that into negative 2b. The other question that we're asked is, where is this arrow going to hit the ground? So that's over here. This is where f of x equals 0. Okay, so like with any quadratic, we can use our quadratic function to find where that's going to equal 0, because we're not going to factor this when we have decimals. It just gets too complicated. But we have, we can use our negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so negative 2 plus or minus the square root of 2 squared minus 4 times a, which is this negative 0.005. C is 5 divided by 2 times, again, this negative 0.005. Okay, when you plug this into your calculator, you get two answers. One with the negative is negative 2.48, and the positive is 402.5. Well, what's this negative 2.48? Well, that's where this arrow would have originated if we follow that parabola back down. That's this point here. Okay, so that's not the point that we want. We want this 402.5 feet. That's our point over here. So whenever you plug something into the quadratic, you have to think about what you get and which one is the appropriate answer. Okay. But again, these are more complicated because usually they have decimals and numbers that aren't like easy to factor. But we treat them the same way. Finding the maximum or the minimum is going to be at our vertex, and we can use our equation for that. And where it hits the ground is where f of x equals 0, and we can use the quadratic equation to calculate that. Okay. The other type of application that we oftentimes see is maximization and minimization problems. And regardless of what these are, we're going to be looking for some sort of quadratic equation that we're looking for the maximum or the minimum of, and those are going to be our vertex. And usually we're given some other equation with some parameter that's part of the problem. So in this case, we have 120 feet of fencing is used to make a rectangular pen. What is the maximum area that can be enclosed? So here we have our area is what we want to maximize, but our area for a rectangle is always our length times our width. So here I've labeled this as x, y. This is going to be x times y. Okay. And they tell us that we have 120 feet of fencing. So the fencing is going to go around this rectangle. So this is our perimeter. And it's going to be, we have x, y, x, y. So we have 2x plus 2y. And here they told us this is equal to 120. So now we can go ahead and solve this for y. We subtract 2x minus 2x. 2y is equal to 120 minus 2x. And we can divide by 2. And we get y is equal to 60 minus x. So we have an equation here for y. We're going to use this equation and put it back into our area equation. So we have our area is equal to x times y, but instead of y, we're going to substitute in this 60 minus x. And we can distribute that x. This is 60x minus x squared, or we can write this as negative x squared plus 60x. Okay, so this is our area. Now we want to find the maximum area. So this is we have our a is -1. It's going to be a downward facing parabola. We need to find the maximum of that. Okay, so here we're just going to be, our x coordinate is -b divided by 2a. Okay, so our maximum area is -b. So this is -60 divided by 2 times a, which is -1. So this is equal to 30. So our x here is 30 feet. Okay. Our y is 60 minus x. So here y is going to be 60 minus 30 is equal to 30. So this is equal to 30. And now our area is going to be x times y, which is equal to 30 times 30, or 900 square feet. Okay, so that's our maximum area that we can create with the fencing that we have. So whether you're doing a fencing problem or some other problem, usually you have two equations. I did want to call attention here is that sometimes we have a fence that's like up against a building, right? If this fence is up against some sort of building here, then our equation for our fence, we don't have to include this side. So our equation becomes 2x plus y. Okay, so you want to be careful that you get the correct equations, and it's going to depend on the situation in the word problem. Okay, and there's other optimization problems or maximum minimum problems, and again, you're going to be looking for two equations and looking to substitute into the equation that you want to maximize or minimize to be able to get into some sort of quadratic equation that you can manipulate. Okay, if you have any questions on these, the Academic Support Center is here to help any RVCC students. So you're welcome to sign up for an appointment. We're happy to help. That's what we're here for. Okay.